In continuation with the previous module, we had discussed the module 1 important questions. So let's move on to the module 2. What are the important questions? So the questions which I have marked with star, I will be focusing more upon, and the questions which I have not marked with star, those I will just touch a few key concepts which you have to remember. Okay. So the first question is, how do you classify the polygon? Explain OpenGL polygon fill primitives. This is a very repeated question. So it's present at page number 5. Let's have a look. So if you move to page number 5, it will show us the identifying of the concave polygons. So the introduction to polygons start from here actually. So fill area primitives. Okay, so what is fill area primitives means? We'll be filling the area of the polygon, or the filled area is called the fill area primitives. Okay, so how do we fill is either by the color or by the wires. Okay, so these are the 2 points which are right in the fill area. And to classify the polygons, so anyways, you listen for the whole thing. What is the main thing, what are the contents you can remember that you have tried in the exam if they asked about the polygon. Okay, next we have the polygon classification. This is divided into two parts, concave and convex polygon. So what is the difference between concave and convex is that in concave polygon you will have it like this. Okay, one of the angles will be greater than 180 in the interior part, and in the convex polygon each of the angle will be less than 180. So we are just concerned with this one. It in this polygon we will be trying to divide and finding out which is the interior area and the exterior area. Okay, so those are the three questions, and these are the two classifications of the polygon. Okay, so it's actually present at page number 4. Then we have identifying the concave polygon. There are two ways in which we can identify the concave polygon. Actually, that's the second question. So if you observe carefully, what are the different algorithms to identify the concave polygons? Write the two algorithms to split the polygons which is concave, and two algorithms to identify the interior and exterior area of a polygon. So this is the important things what can be asked in the polygon. The rest of the topics I'll discuss later, but these are the 4 types of questions which can come under the topic of polygon. Okay, so let's get started with the first topic, which is the identifying the concave polygon. In the identification, there are two algorithms. The first algorithm is by the cross vector method. In cross vector method, what we do, you just have to explain the theory. Okay, you do not have to actually calculate these values. So what you have to do is write a theory about it. How does the algorithm work? So you'll get to know the theory after my explanation. So what you have to do is first you have to write this diagram. Okay, so in this diagram what you have few edges here, and one of the edges will be greater than 180. Like this angle will be greater than 180 here. Like that angle you have to make. Okay, after you have made that angle, then what we'll be doing is we'll be classifying the different cross vector products. Sorry, you have to make this angle as more than 180. So this is the angle which is interior angle more than 180. Okay, that's what matters. After I have made this diagram, you have to find out the cross product. Okay, this need not find actually the cross products. All you have to say is that this cross product will have less than 0, the values less than 0. If I zoom in, all the values of the cross product will be greater than 0 except this one. In this, E3 cross E4 is less than 0. E3 cross E4 is this one. This is E3, this is E4. This is less than 0 because the angle is greater than 180. Okay, in that case you will get as less than 0. In this way you can identify which of the lines form a polygon which is concave. Okay, that's one of the algorithm. The second algorithm is by, so it's not much information is given. So what is there is, look at the polygon vertex position relative to the extension line of any of the edge. If some vertices are on the one side of the extension and some vertices are on the other side of the polygon, then it is a concave. So for example, if you are looking at this one of the edges here and one of the edges here, right, it's like bulging out. So in that case we can identify there is a concave polygon here. So those are the two algorithms for identifying the concave polygon. Anyway, it's not asked much in the exam. And let's move on to the next one, which is splitting the concave polygon. There are two methods in which you can split the polygons. The first is the vector method, the second is the rotation method. Okay, so let's see what is the key concepts in both of these. In the vector method, what we will do is we'll be having the vector values, cross product values again we will calculate, and whichever the cross product value we get as negative or some other like different than the normal vector product, that will identify the edge as that is the edge which is to be cut. Okay, so in this case we will identify that this is the edge which is to be cut because the angle is greater than 180. So in this case what we will do, we will extend this edge. Okay, we will extend this edge till here. When we extend this edge till here, this is one of the polygon which is getting formed, and this is one of the polygon which is getting formed. Like that we will be splitting the polygon into two polygons. Then we have the rotational method. In rotational method what we do, see this is the polygon which is given to us, right? So if you have to make this as a separate polygon, this is the x-axis, this is what the x-axis, right? What I will do is I will take this polygon and I will rotate this polygon in this direction. I will rotate this polygon in this direction so that this edge falls on this one. So what will happen, in the bottom of this edge I'll have a triangle like this piece I'll cut off, so I'll be remaining with the remaining triangle on the top. So that's what the splitting of the polygon is. That's the rotational method, the second method. Here I'll get this edge, I'll cut off this edge, and I'll be remaining with this remaining part. That's the rotational method to split the polygon into two parts. Okay. The next one is the identifying the interior and exterior region of the polygon. This is the fourth question. So here two rules are used: inside outside test and a non-zero winding number rule. This is very important question from exam point of view. These two tests you have to explain along with a relevant diagram. So what is the test is inside outside test means, suppose that I'll explain the diagram. First you make this diagram. Okay. Now when you have considered this diagram, consider this point here. When you're coming out from this point, you are encountering how many edges? 1, 2. If you encounter even number of edges, it is exterior part. Okay. And if you encounter odd number of edges, like only one edge you encounter and come out, that is the interior part. Like that you have to identify. Okay. So how you can remember is, just take a point outside. How many edges you encountered reaching outside? 0 points, because you are taken this point outside only. So 0 is an even number, it is the exterior part. Like that you can remember. Okay. And the other one is the non-zero winding rule. In non-zero winding rule, what will happen is, you will have this edge here. Okay, and you will be making the arrows like this. This is one arrow and this is one arrow like this, which is coming here. Now you have considered these two arrows. Now while coming out, if you are going from right to left, okay, consider this as right to left and this as left to right, or from bottom to up as +1 and from top to down as -1. Okay. After you have done that, when you are encountering it like this, okay, you are coming out like this, again you are coming here like this. So once you encountered from bottom to up, again you encounter bottom to up. So it will cost means give you the answer 2. If you get an answer which is greater than 0, that is the exterior point. If you get an answer which is less than 0, that is the interior point. Okay. So that's how you identify the exterior and interior points using non-zero winding rule. You need not explain in depth, you just have to explain what you will get when you go out and when you come in. Okay. So here is the thing. We add 1 to the winding number every time we intersect a segment that crosses the line in the direction from right to left. When you are moving from right to left, add 1 to it and subtract 1 when we intersect the segment that crosses from left to right. And right to left can also be taken from bottom to up, and left to right can be taken from top to bottom. If you explain this point with a relevant diagram, that should be sufficient for you. Okay. Moving on, we have the next question, which is what is the polygon table, and explain with a neat diagram and example. So what is polygon table? I'll just give a brief overview since it's not much repeated question. So this is the polygon table. In the polygon table, it can be categorized into two groups: geometric table and attribute table. Okay. So basically, if you have this diagram here, as you can see, E is the edges, V is the vertex values, and S is the surface area. So this is the vertex table, this is the edge table, and this is the surface table. In this, what is the information you can find is, what is the vertex values, XYZ values, and what is the edge means which two vertices form an edge, and which are the edges values that form the surface. This is known as the polygon table. Just have to write this and explain each table with a relevant diagram on top of it. Okay, that's all what is there in the polygon table. Let's move on to the next question, which is what is the plane equation and how to identify the front and back face of the polygon. So what is the plane equation? The plane equation, this equation you have to write and write some points regarding it. Ax plus by plus cz plus d. So what is xyz, what is the coefficients abcd, that you have to write, and after that what you will be writing is, you will be having, using Cramer's rule, these values for abcd. Okay. And after that you will be getting some values for that, if it is greater than 0, less than 0, or not equal to 0. Based on that, you will be identifying if it's in the front or back of the polygon faces. The first case, if it is not equal to 0, then it's not belonging to any of the faces of the polygon. If it is less than 0, then it is behind the plane. If it is greater than 0, then it is in front of the plane. If it's equal to 0, it lies on the surface of the plane. Okay. So that's all what you have to do in the plane equation, and how to identify the front and back face of the polygon. The next important question is the super important question, which is what are the different polygon fill functions. It's presented page number 15, so let's go to that. Here you have the different polygon fill area functions. So what are the different kinds of polygon that are possible? Let's have a look. The first is just the polygon you will write with n number of sides. So whatever the number of sides you mention, in that way the polygon will be made. The second type is the triangles. In triangles also you have three types, which is the GL triangles, GL triangle fan, GL triangle strip. Okay. So based on that, the different figures will be formed. Either it will have a loop or it will have a division in between. So those are the different types of triangles. As well as in the quads, we have the GL quads, a simple quad will be formed. If you use the GL quad strip, this kind of quadrilateral will be formed. Okay, so these are the basic things which you have to explain in the, if they ask about the polygon fill area functions. Next, the important question, which is a general polygon scanline fill algorithm and numerical. Okay, so it's presented scanline PDF. So in that folder you can find out there's a PDF called as scanline, which if I show you here, this is the PDF which you have to refer for the scanline problem. So the algorithm you have to write by your own. I'll be explaining the diagram what you have to do, and step by step you can write the algorithm, because if you see actually what is the algorithm, that is very hard. Okay, so based on your understanding you can write the algorithms means point wise, that should be sufficient for you. So here's the type of the question that can come in exam. I explain the data structure used by the scanline polygon fill algorithm. There are two data structures, two tables are used, so that I'll be discussing. And what is the content of the active edge table to fill the polygon with the vertices A, B, C, D. 4 points will be given to you, so 4 points you have to write it like this: A, B, C, D. Just mark it on the plane, and after that you have to sort the edges. Sort the edges means first you have to write A, then B, then C, then D, based on the x values. X is 2, 2, 4, 4, and after that you will be sorting it. So when you sort it, it will be like this: 2, actually with the y values you have to sort, not the x values. So 4, 6, 7, 9. Based on the x values you will be sorting, y values you will be sorting, and in each iteration you will be doing y plus plus. Okay, whatever the points I tell, mark it down carefully. Each point you will do y plus plus. Just the question is whether you will do x plus plus or not. Whether you will do x plus plus or not, that's the main question. Actually you will not do x plus plus, you will do x plus 1 by m. You will find out the slope and you will add x plus 1 by m. To be more clear, after you have sorted the values, you have to make a table like this. Okay, this is one of the tables, sorted table. Here you have to write y values from 1 to 9, and you have to mark A, D, B, C in the increasing order, what y values you had. Okay, then we'll come to this later what it is. Basically when you see this diagram, you have to start from the least point. The least point is A, and it's connected to two edges AB and AD, right? So what you have to do is you have to start from here and note down these 2 points, 2, 4 and 4, 6. For these 2 points you have to find out 3 values: y max and y min, x and 1 by m. These 3 points you have to find out for these two, means these 3 things you have to find out for these 2 points. Okay, so 2, 4 and 4, 6 is given, right? What is the maximum y value among this one and this one? It is 6, so write 6 here. What is the minimum value? 4. What is the corresponding x value? 2, so we'll write 2 here. What is 1 by m? What is m first of all? 6 minus 4 by 4 minus 2, right? This minus this minus divided by this minus this. So 6 minus 4 is 2, 2 by 2 is 1, so 1 by m is also 1. So after you have written this much, what you have to do is you have to write this in the corresponding table. From A you will be writing that what I mentioned. So you will be writing here 6, 2, 1. Either you can write this first or this first, that doesn't matter. Okay, so for AB, if you do like how I did for AD now, if you do for AB, you will be writing that here, and same thing you will do for the remaining 2 edges, this one and this one, in the corresponding D and B places. For B you will write, and for D you will write. After I have written this much, you have to do few steps. Okay, you will be starting from here and you will be reaching here. If you consider first edge at this time, basically what we are trying to do is y value will increment each time. Okay, so make a table like this. It doesn't matter how you write, either you can write in the box form or you can write in the table, but the thing is what content you write, based on that you will get marks. Okay, so make sure the content is correct. So y value, as I told, it will always increase in the every iteration. So this is 4 and 6, so 4, 5, 6 it will become. What I am trying to find out is when it is 4 the value is 2, when it is 6 the value is 4. I am trying to find out when the y value is 5, at that time. See, 4 I know, 6 I know, the value of x is 2 and 4, but for 5 what is the value? I am trying to find out this corresponding value. What is at this axis, that corresponding value I am trying to find out. So how I will find out is, already I told you what is the first point, 2, 4, and to add to get the next x value, what I will do, x plus 1 by m. M I had calculated as 1, so 1 by m is also 1, so x plus 1 is 3, so it will be 2, 3, again I will add 1, it will be 4. So this is the final point, as you can see, 4, 6 I got. So 3, 5 is the point which I have to mark here. Okay, like that it will fill like this, it will mark this point, then it will mark this point, and when I consider this edge I will get this point as well, then I will get this point is present here, and when I consider this edge I will get this point. Like that I will keep on doing for all the edges. Okay, So if you want more information regarding this, you can watch the module 2 video. There I explained in depth how to approach this question. Okay, so since time is limited, I will not be repeating the same thing. And finally what you get is after drawing the active edge table, and you have to mark the pairs like this. Whatever the points you get, that points you have to mark, and all these steps are explained in depth there, so you can watch that if you have any doubts here. And yeah, that's all what you have to do. And the algorithm also will write as same. If I give you a brief overview how to write the algorithm, first what you are doing, you are given the points, sort the points accordingly. After sorting, you will make a table like this, and you will be marking those values here, the y max, y min, x value, and 1 by m. After that, you will consider each edge. In each edge, you will be doing y plus plus, and you will be doing x plus 1 by m. You will be finding out x values until x will become means it will reach the end point. You will do the same for all of these. Then you will write the coordinate values here. After that, you will be filling those values. That's all what you have to explain in the algorithm as well. If you explain it properly, you will get the marks. Okay, so that's all what is there in the general scanline fill algorithm. A very important question from exam point of view. Okay, so let's move on to the next question, which is explain the 2D basic geometric transformations, translation, rotation, scaling. See here, the both theory as well as the numericals can come. Okay, both the theory as well as the numericals can come, so pay attention. So what are the different types of numericals, what are the different type of theory questions, what is the matrix values, that I will be discussing now. So at one go I will be explaining this one, translation, rotation, scaling, homogeneous translations, rotation and scaling, inverse translation, composite, general 2D pivot, fixed scaling, and rigid body transformation, and other transformation, reflection, shear. Any of these they can ask. Okay, which is the more important one that I will be discussing now. So let's move on to the first the printed notes. There we will be discussing the theory. After that we will be discussing what is the numericals associated with that. For that there is a separate PDF. Okay, so let's move on to the 2D geometric transformations. So starting from the translation means what? Translating the point from one point to another point. So if the point is x comma y, so assume that the point is x comma y, and this point is x dash comma y dash. What you are doing is you are adding some value to x so that it is getting transformed here. You are adding some value to y, so it is getting transformed here. So the x value and the y value corresponding, it will be transformed as such. Okay, so if you write it in the matrix form, it will be like this: x dash is equal to x plus tx, y dash is equal to y plus ty. Ty and the tx are the how much you have to transfer in the x direction and how much you have to transfer in the y direction. And in the matrix form it will be like this: p will be the initial position, and this will be the final position. T is how much t means how much translation you want to perform in the x direction, how much translation you want to perform in the y direction. So p dash will be equal to p plus t. You'll be adding these two matrices to get this matrix. Okay, so that was about the translation. And in the rotation you have the anti-clockwise as well as the clockwise. So in the question, if they don't give you anything like rotation, you have to take by default anti-clockwise. By default you have to take anti-clockwise. Okay, so the thing which you have to keep in mind is this equation, this diagram means matrix equation: cos theta minus sin theta cos theta. By using this matrix, you will be multiplying with the corresponding point to get the final point. Okay, that I will be discussing in the numerical part. For scaling, you will be using this matrix Sx0 0 Sy. With the corresponding point you will multiply to get the final point. This was about the normal basic transformations without homogeneous. Then we have the topic which is homogeneous. Homogeneous mainly for the 3 cos 3 matrix. Why we are using homogeneous matrix, that reason is also given here. A convenient choice is simply to set H as 1. Each two-dimensional position is then represented with the homogeneous coordinate x, y and 1. We are using this because when you perform the composite transformations and the inverse transformations, it will be much simpler if you use homogeneous coordinates. Okay, that's why we are using the homogeneous parameters. Okay, so here just the same thing, the two-dimensional translation matrix will be transformed into three-dimensional. Before what we had, just we had two terms here, this much matrix only was there, and tx and ty was present here, right? If I show you the previous one, translation was just 2 cross 1 matrix, 2 rows and 1 column. See here, there are 2 rows and 1 column. That's all what was there, and we are just adding it. But in the homogeneous, we are not adding, but we are multiplying it. So how are we multiplying it? We will be having some values here, and that will be multiplied with the corresponding point to get the final point. Same thing goes for the rotation as well. The cos theta minus sin theta and cos theta, that will be written here 0 0 0 0, and last we will be writing 1, and that will be multiplying with x, y and 1. what you will be multiplying with? X, y and 1 to get the final values, x dash, y dash, and here it will be 1 only. That is for the rotation, and this for the scaling. Make sure what the question they have asked, based on that only you have to write. If they ask for homogeneous, you have to write this one, else you have to write the previous one only. Okay. Then we have the inverse transformations. It's the same thing. Here instead of plus you will be writing minus, and here wherever it was minus, like here it was minus, you will transform that to here. And for scaling it was sx and sy, you will write 1 by sx and 1 by sy. Okay. So these three things what you will do in the inverse transformation. If they tell you to perform the inverse transformation, you will write x, y and 1 with this one and get the final points. Okay. Then you have the composite transformations. Composite means mixing two or more equations. So if you want to do two translations, one from here to here, then from here to here, you can take these two matrix values and then add it up. So if you add it up, means in this case it is multiplying. If even if you multiply, it will be t1x plus t2x, the final position of x, t1y plus t2y, the final position of y. It actually makes sense. If you are doing the translation 10 units, then 20 units, the final will be 10 plus 20 only, and same goes for y also. So we will be writing the composite in a same matrix. Two dimensional rotation also, it's the same thing. You will be adding the theta values. Scaling is also the same thing. You will multiply the two scaling factors. But the point comes when you have to do either translation plus rotation, rotation plus scaling, scaling plus translation, or a mixture of any of these two things. At that time the difference in the equation comes. Okay, it's not pretty straightforward at that time. So that will be discussing in the numerical part, the composite transformations. Before that, you have to know the two-dimensional pivot rotation, a fixed point rotation, and rigid body transformation. So pivot rotation means if you are present here and you have to perform the rotation, you cannot perform the rotation as such here. The xr and yr are the points where the triangle is presented. First you have to transform this to the origin, because the formula is defined for the origin. The rotation formula is defined for the origin itself. You cannot use the rotation formula for this one. So you have to transform it here, then rotate it, then inverse translate it. Here comes the relevance of composite transformations. Okay. So here's how you perform the composite transformations. First you will translate it to the origin, then you will rotate it, again you will retranslate it. If you multiply these matrices, you will get a single matrix value. That's what you will use for the rotation. And for each point you will be multiplying x, y and 1, you will get the corresponding points, the final points. Okay. For the whole triangle you will do the same thing. Fixed point scaling is also the same thing. Translate it to the origin, scale it, again retranslate it. Okay. And general two-dimensional scaling directions. So this is not much repeated question. Matrix concatenation properties, general two-dimensional transformation computational efficiency. This is just for your knowledge, but from the exam they don't ask much regarding these topics. Rigid body transformation is also same thing. It's not much asked. Constructing two-dimensional rotation matrices. Okay. So those were the concepts regarding the general pivot point and general scaling, fixed point scaling. Okay. And in the numerical I will discuss how to actually perform those calculations using matrix values. And this is the last topic from the two-dimensional transformations, reflection and shear. In this both the theory as well as the numericals are asked. Okay. So reflection, this value you have to remember. If you have to perform the reflection about the x-axis, what I mean is, if you have a triangle here, actually there is a diagram, I will show you the diagram itself. So this is the original position, and after the reflection this is the position. If you have to perform the reflection about the x-axis or y is equal to 0, at that time you will be using this matrix. The 3 points of the triangle, you will multiply xy1 with this one, you will get the final points for xy1. Like that you will do for all the 3 points, you will get the final 3 points in the reflected manner. This is the matrix which you have to multiply the xy point with. For the 3 points if you do, you will get this answer. Like that the different possibilities are there. If x is equal to 0, this is the reflection point, you will be means it is like this. Okay. So if this is the original position, we will be reflecting it in this position, and this is the matrix for the different purposes. Basically you just have to remember this one. Okay. If this one, if you remember, the problems are also not asked much in the reflection, but in shear they have asked the problem as well. So reflection you just have to explain this one, and if you can explain this one, that will be more better for you. Okay. So coming to shear, shear means you are just pulling it. Okay. If you are pulling it in the with respect to y-axis, the y value will remain constant, only x value will change. If you are doing shear with respect to x-axis, the y value will remain constant, only x value will change. So in the equation you just have to change the x values. So what you have to do is, if you are okay, anyways I will be explaining this in the numerical, that will make the things more clear. So let's move on to the numerical. This is all what is there in the 2D transformations. The rest of the topics, the raster method for geometric transformation, these are not must asked, so I have not included them here. So anyways, let's move on to the numerical PDF. There one numerical is there for each of these concepts which are discussed, so I think that should be sufficient. So see here, they translate the square having the coordinates 0 0 2 0 0 2 and 2 2. For the translation, what I told, tx and ty value will be given 2 3. What you have to do is add 2 to each of these x values, add 3 to each of these y values. Using the matrix, if you add, you will get the final positions that you have to mark. Okay, after marking, you will be writing it like this. Translate the triangle, again the same thing. The x value and the y values are given, tx and ty. For each of these points, just apply the tx and ty values for the x and y values respectively. You will get the final points, mark it. Okay, so this is the translated matrix. Then we have rotate the triangle. For the rotation, first see what is the angle. If the angle is given as means whatever the angle is given, note it down. And the second thing you have to note it down is it anti-clockwise or clockwise? If they are not given anything, it will be obviously anti-clockwise by default. Okay, so here they also mentioned by default always take as anti-clockwise direction. So for anti-clockwise direction, write this formula. After that, you will be taking 90 degree and applying the 90 degree here, and what answers you get, that will be multiplying with each of these points. So you will get some final points that you have to mark in the diagram. Then we have rotate the triangle in 90 degree with clockwise. So write the clockwise formula. Just the difference is the minus which was here, that gets shifted here. Okay, that's all, and you will multiply the xy values to get the final xy values. Scaling is also the same thing. If you remember this matrix, sx sy, multiply here, means substitute the sx sy here, multiply the matrix with each point, you will get the final positions for each point. Okay, demonstrate the 2D rotation of a triangle with respect to origin, arbitrary point. Okay, see here is the relevancy of composition transformation. What you will do is, see, they have given an arbitrary point, it's not in the origin. So first you have to translate it to the origin. For that you will be using the tx value. Okay, so this is the value which you will be using, xr and yr. So you will be translating it, then you will be rotating it with what angle they have given, substitute that here, and xr yr value also they have given, substitute that here. This is the arbitrary point, is the xr yr value, and this is the 3 points you have to multiply the final matrix with. After you have done this one, inverse translation after the rotation, you will get this matrix, multiply it and keep it here. This matrix is have to be multiplied with 0 0 1 0 and 1 1 in this way. This is 0 0 1 0 1 1. After that, what answers you get, this is the xy value, xy value, xy value. Mark these 3 points, that's the final diagram which you are supposed to get. Okay, that's all what is there in the 2D transformations. And finally you have the shear and the actually the reflection is not must asked, this is the theory is asked, but shear is asked. Okay, so here's a mistake which I wanted to tell, like the equation. Here it is not x plus shx. Okay, it is actually sorry, this is the same thing. Okay, sorry. What they have mentioned is x into y, that they have written here first, so I thought it is a different one. So anyways, you can expect a question like shear the given means points. So points will be given, 4 points will be given, and the shx value will also be given to you. What you are supposed to do is you have to mark these 4 points in the diagram, then shear it with respect to x if they give, or y, 2 units. What you have to do is, if it's with respect to x, only x will change. As I told you, shearing with respect to x will change only the x value, y will be remaining constant. Okay, so y will be remaining constant, y dash will be y, whatever the y value is present in each of these, that will be the same. X value will change as x plus shx into y. You have to multiply the corresponding y value with shx, what they give, and add the x value to it. For example, see here the 4 points are 0 0 2 0 0 2 and 2 2. We are doing with respect to x, therefore the y remains constant, y value is 0 0 2 2. So I have written 0 0 2 2. Next, the x value is getting changed, right? So if the x value is getting changed, what you have to do, you apply this formula, x plus shx into y. What is the x value here? It is 0. So 0 plus y value is 0 and shear value is 2. 2 into 0 plus 0, it is 0 only, so we will be writing x dash value as 0. In this case, x value is 2, so you have written here 2. 2 into y value is still 0 only, because 2 comma 0. Here it is 0 comma 2, so 0 added with x, and 2 is the y value getting multiplied with shx into y plus x. So that answer what you get right there, and based on the in the same way, same thing goes for here also. For the y, what will be changing is only the y, x will remain same. So first write x as same, then for y values what you will do, y plus shy into x. Make sure this difference is there. Okay, shy is getting multiplied with x, not y. Okay, shy into x and shx into y in that case, and you'll be multiplying that and finding out the final y values. Okay, So this is mostly what is asked in the numericals from the module 2. And let's move on to the remaining concepts. What are there in module 2? The remaining concepts are not much repeated except the last one, raster method for the transformation, OpenGL for raster transformation. And let's have a look at that. It's at page number 52, raster methods for transformation. So it's in the other PDF printed module 2. So it's in page number 54. Okay, so what is the raster methods? In raster methods, we'll be having the see, this value will be stored. Okay, these values what you can see here, that will be stored. Where it will be stored? In a frame buffer. Raster stores the picture information as color patterns in the frame buffer. These values will be stored. What is the diagram? After this is stored, if it has to be displayed in some other location, only the values will be subtracted from this one so that it is visible in the other location. That's what the raster operation is. Okay, it can be used for the rotation as well as for the translation, as well as for the scaling. That's all what is in the raster transformation. And for the raster transformation functions, you will be using copy pixels, read pixels, the same thing what I have mentioned here, but this is actually never asked in the previous papers. So you can just have a look once for this question. Then we have the OpenGL functions for two-dimensional geometric transformations. So this is what translate, rotate, and scale, and matrix mode, load identity, load matrix. This already we have studied in the lab programs, right? The same things are mentioned here. Okay, including some other few things, like to multiply matrix we can use the shortcut functions, inbuilt functions. And after that we have the two-dimensional viewing. Okay, in two-dimensional viewing pipeline, it's the important question. So basically you have to explain what is x world coordinate and viewing coordinate. In the world coordinate, you will clip the whole picture, and after that what is the thing which you want to view, that is the only thing which is required, right? So that you will be cropping it further. So the top part is the world coordinate, the below part is the view coordinate. For each of this you have xw min, xw max, yw min, yw max, and here you have xv min, xv max, yv min, yv max. Okay, and the viewing pipeline, this is very important. It's compulsory for you to make this diagram. This same as I told in the module 1, there is a world coordinate transformation, right? From modeling coordinate MC to world coordinate WC to viewing coordinate VC to normalized coordinate NC to device coordinate. How I told you to remember in module 1, in the same way you have to remember here also. As I told you, it's an important question. It has been repeated in 2 or 3 modules, right? This is the second repetition of the same question. Here you have to translate it from the modeling coordinates to world, viewing to normalized to device. Inside of this also you have to write the same thing. Construct the world coordinate scene using modeling coordinate. Then you have to convert the world coordinate to viewing coordinate, transform the viewing coordinate to normalized coordinate, and transform the map the normalized coordinate to device coordinate. These are the transformations you will do, and based on that you will be writing the information regarding this, what is model, world, viewing, normalized, and device. Okay, just the information regarding that you will be writing. I had explained in module 1 what you have to write in this type of questions. Okay, so after that it's not important, just it's the different types of functions used. So that's all what is there in the module 2, and make sure you hit the like button, subscribe to my channel. If you have any doubt, you can text me on Instagram, and thank you so much for watching. I'll see you in the next one.